Hi dear children, today we are going to discuss exercise 13.4. First question, state which of the following are not the probability distributions of a random variable. Give reasons for your answer. Just look at the first table and P of x 0.4, 0.4, 0.2. And if you want to check the given is a probability distribution or not, we need to check two conditions. First one, all the probabilities should be greater than 0, and second one, sum of all probabilities is equal to 1. Here all the probabilities are greater than 0. Now just check the sum. 0.4 plus 0.4, 0.8, 0.8 plus 0.2, that is 1. So the first one is a probability distribution. Now second one, in that second table, just look at that second table, we can see one negative 0.1 there, right? Negative 0.1, that means one probability is less than 0. Therefore, the given table is not a probability distribution. Now third question. In the third question, this is our third question, and P of y 0.6, 0.1, 0.2. 0.6 plus 0.1 plus 0.2, that is 0.9, right? All the probabilities are greater than 0, but that sum not is equal to 1. Therefore, that is not a probability distribution. Now, fourth one, all the probabilities are greater than 0, but the sum you will get it as 1.05. Sum you will get it as 1.05. That exceeds 1. We need to get the sum is equal to 1. Here that is not equal to 1. Therefore that is not a probability distribution. Now fourth question. Find the probability distribution of first one, number of heads in two tosses of a coin. Second one, number of tails in simultaneous tosses of 3 coins. Third one, number of heads in 4 tosses of a coin. Okay. So we need to write the probability distribution in this case. To write the probability distribution, I am going to write the sample space corresponding to that experiments. First one, 2 tosses of a coin. For question, first one, sample space is equal to 2 tosses of a coin. The sample space H, 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 T, T, H and T, T. This is the sample space corresponding to the experiment of coin tosses 2 times. Okay. Now, X number of heads. That is our X in the first case. Number of heads. The first outcome we have 2 heads. Second outcome 1 head. Third outcome 1 head. And fourth outcome 0 head. That means the possible values of X are 0, 1, 2. Okay. The possible values of X is equal to 0, 1 and 2. Now we need to write P of X because we need to find out the probability distribution. P of X, the total number of outcomes, that is 4. Now, how many outcomes gives X is equal to 0? How many outcomes gives X is equal to 0? Only one outcome gives X is equal to 0, so 1 by 4. Now, how many outcomes gives X is equal to 1? These 2 outcomes gives X is equal to 1 because in that 2 outcomes, the number of heads is equal to 1. So, this is 2 by 4 and this one gives X is equal to 2. So, probability is equal to 1 by 4. This is our probability distribution corresponding to the experiment of tossing a coin 2 times and X is equal to number of heads. Okay. Now, second question. Number of tails in the simultaneous toss of 3 coins. Here we are going to toss 3 coins. Then the sample space corresponding to that 3 coins. Second one, sample space is equal to total number of outcomes in coin tossing experiment, that is 2, and if it tosses 2 times then 2 raised to 2, and if it tosses 3 times that is 2 cube. So we will have 8 outcomes here. That is H, 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 T, H, T, H T H H H T T T H T T T H T T T. Okay, this is our 8 outcomes. Now, X in this case is number of tails. Number of tails. Okay, consider the first one. 0 tails are the 1, 1, 1. Okay, and in this outcome we have 2 tails, 2 tails, 2 tails and 3 tails. So the possible values of X is equal to 0, 1, 2, 3. The possible values of X is equal to 0, 1, 2, 3. Now 0. How many outcomes gives X is equal to 0? Anyway, the total number of outcomes here it is 8. Now, how many outcomes gives the total number of heads is equal to 0? Total number of tails is equal to 0. This one, only one outcome gives the total number of tails is equal to 0. Now, 3 outcomes gives number of tails is equal to 1. 1, 2, 3. This is our 3 outcomes. Now, again 3 outcomes gives number of tails is equal to 2. 1, 2, 3. This is our 3 outcomes which gives X is equal to 2. And the last one, in that case X is equal to 3. 1 by 8. So this is our probability distribution corresponding to this experiment. Okay. Now third case, number of heads in 4 tosses of a coin. Number of heads in 4 tosses of a coin. Here, if you are going to toss a coin 4 times, we will have 2 raised to 4 outcomes. That is 16 outcomes we will have in this case. 16 outcomes we will have in this case. This is the sample space corresponding to a coin tosses 3 times. Right? Now, we need to find that 16 outcomes in the case of tossing a coin 4 times. What I am going to do is I am going to take the cross product of these two. This is in the case of 3 coins and this is in the case of 1 coin, or 3 times or 1 times. Then if you took the cross product, we will get the sample space corresponding to the experiment of tossing a coin 4 times. That sample space S is equal to first element H, 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 and the first element from this, that is H. Again H, H, H and T. Okay. Now take the second element and take the combination with these 2 elements. H, H, T, H, 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 T, T. Now third element H, T, H, H, T, H, T, T, H, H, T, H, H, T, H, T, T, H, H, T, 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 H, T, T, H, T, 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 H, H, T, T, H, T, 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 H, T, T, T. Okay. This is our 16 outcomes. This is our sample space corresponding to the experiment of tossing a coin 4 times. Now, in this case, the random variable capital X is number of heads. Number of heads. So, the possible values for X is equal to 0, 1, 2, 3, 4, because in this outcome we have 4 heads and in this outcome we have 0 heads. So the possible values for x is equal to 0, 1, 2, 3. Now we are going to find out the probabilities. P of x. How many outcomes gives x is equal to 0? Only one outcome gives x is equal to 0. That is this one. So the probability is 1 by 16. Total we have 16 outcomes. And only one outcome gives x is equal to 0. Now x is equal to 1. 4 outcomes gives x is equal to 1. That means in 4 outcomes we have only one head. Okay. So that is 4 by 16. Now x is equal to 2. That means how many outcomes gives 2 heads? How many outcomes gives 2 heads? That is 6 by 16. 6 by 16, and x is equal to 3, we will get 4 by 16, and the last one, that is 1 by 16. Now if you want to check whether this is correct or not, just add all these probabilities. 6 plus 4, we will get it as 10. 10 plus 1, 11. 11 plus 4, 15. 15 plus 1, 16. 16 by 16, we will get it as 1. So this is the probability distribution corresponding to the experiment of tossing a coin 4 times. Okay. Now, fifth question. Find the probability distribution of the number of success in 2 tosses of a die where a success is defined as number greater than 4. 6 appears on at least one die. 2 tosses of a die. 2 tosses of a die, that is very important question. And we know that if we have a single die and single throw of a die, we will get 6 outcomes, right? Single throw of a die, we will get 1, 2, 3, 4, 5, 6. This is our 6th outcome. Then if we are going to throw that die 2 times, then we will have 1 times 6 outcomes, 2 times 6 square, that is 36 outcomes we will have. Okay. Now we are going to define one random variable, capital X. Capital X be the random variable which denotes the number greater than 4. Which denotes the first case, which denotes the number greater than 4. Capital X be the random variable which denotes the number greater than 4 in 2 tosses of a die. Okay. Then X takes the values. We are going to toss it die 2 times, then we will have ordered pairs, right? We will have ordered pairs there. Then a number greater than 4. Sometimes these 2 numbers less than 4. Okay, then 0 will be the value of X. Sometimes the first number or the second number, either the first number or the second number may be greater than 4. Then X is equal to 1. If these 2 entries, and the first entry and the second entry, that numbers greater than 4, that 2 numbers greater than 4, then X is equal to 2 we will get. Now we need to write the probability distribution corresponding to this, right? So P of X, P of X. So what I am going to do is, I am going to write the sample space corresponding to this 36 outcomes. I know that it is not simple, but 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. The last one 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. This is our sample space in this experiment. Now 0. No number greater than 4. How many outcomes are there left? No number greater than 4. 1, 2, 3. Okay, no number greater than 4. 1, 6, 1, 4, is it possible? Yeah. That is not greater than 4, equal to 4. 1, 5, is it possible? That is not possible because 5 is greater than 4. So 1, 6 is not possible. 2, 1, 2, 2, 2, 3, 2, 4. 3, 1, 3, 2, 3, 3, 3, 4. 4, 1, 4, 2, 4, 3, 4, 4. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16. 16 numbers which gives a number greater than 4 or which gives x is equal to 0. Which gives x is equal to 0. So this is 16 by 36. Now at least one number, that is x is equal to 1. At least one number greater than 4. At least one number greater than 4. That is also 16 outcomes gives at least one number greater than 4. Now both the numbers are greater than 4. Both the numbers are greater than 4. 4 outcomes are there with both the numbers are greater than 4. So this is our probability distribution corresponding to the first case. And what is our second case? 6 appears on at least one die. 6 appears on at least one die. Then I am going to define a random variable x. Let x be the random variable which denote the number 6 appears on at least one die. 6 appears on at least one die. Okay, at least one die. Then at least means minimum. Minimum one entry should be 6. Then two possibility are the no entries will be equal to 6. Probability of a number in which 6 does not appear. 6 does not appear, that is x is equal to 0, and 6 appears on at least one die. So here we have two possibilities and the probability 25 by 36, that is our first probability, and in 25 outcomes there is no 6. 25 outcomes 1, 2, 3, 4, 5. Okay, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, 25 outcomes are there with x is equal to 0. And at least one die, at least means minimum, maximum 2 will be there. Okay, minimum one die shows 6. Okay, that is 11 by 36. 11 by 36. So this is our probability distribution in second case.